The next step in fitting, instead of fitting to a straight line, let's fit to a curve of some type. And let's look at the first kind of curve. So I'm going to insert a graph here of experimental data points. Now, when we talked about graphing, we talked about changing the scale of the axis right over here. Format axis. And let's change the scale to a logarithmic. And I think this looks kind of logarithmic. I don't. Yeah, logarithmic is a good thing to try. Now, what we are actually doing is what's called linearizing the data. We're not actually making the data linear. You'll notice the scale over here is powers of 10 now. 10, 1. The distance between 0.1 and 1 is the same as the distance from 1 to 10. It's called a logarithmic scale. And I'm going to get a drawing tool out. What it's telling us, come on, select up there, I want to select up a pen, that the logarithm of the y values equals some slope times x plus b. Now, if we take the exponential of both sides, well, the exponential of the logarithm is simply the number itself, y, equals e to the mx. Ooh, somehow my drawing tool is not taking very well. E to the mx times e to the b. Okay, this is what's called an exponential model because it's exponential. You get this model when the scale of when you change the graph so that the scale of the y-axis is on a log scale, that the points appear to be on a straight line. And y equals the exponential of something times x. Exponential model you get from changing the y scale to a logarithmic scale. And the points appear to be a straight line. So now let's insert our trend lines. Let me get rid of the line I just drew. And go back. I see. I'd be able to select it. Oops, I'm still in my drawing tool. I got to turn off my drawing tool. There we go. Select my chart. There it is. Chart tools. Add chart element. Design. Add chart element. Trend line. More trend line options. Now, what Excel does is it does a linear fit of the logarithm of y to x. So let's type the exponential model, and there it is. We're going to display the equation. And remember that r squared helps us out with understanding if it's a good fit or not so good fit. And I'm going to make the box bigger so you guys can see it. There we go. Go back to my trend line. Just click directly on the trend line. You get the trend line options up again. Do I need to change anything else? No, that's not it. Now let's try just the other options. Logarithmic. Okay, so logarithmic doesn't like the fact there's 0 values here. Control Z. There. I got my exponential back up. It doesn't like logarithmic for the same reason it's not going to like power. And it doesn't even give me the option of power. Control Z. It just doesn't do anything. Moving average is for like sales numbers. It's good for business people. Polynomial, that can fit an elephant. It's generally not scientifically based. Logarithmic, linear, exponential, and power are what we consider to be the scientifically based kinds of fittings. There are others, like an Arrhenius plot and things like that. But we'll get into that a little bit later. How do you linearize the data? This is how we linearize it, that we are doing a transformation on the y-axis and we get a linear model. Oh, now we can just fit the linear model and do the calculations so that we can get mx and b. So e to the b is 8.3815 and m is negative 0.436 from this equation we get up here. Okay, that is the exponential model, and points appear to be a straight line when the y-axis is on a logarithmic scale. Okay, let's take a look at the rocket equation. Here's the data for that. And do the same kind of technique. Ask what happens if we change the scale on the y-axis. And make that a logarithmic scale. It's got a 0 value, so can't do it. Let's try and it's not plotting the 0 value properly, but it plots every other values on a logarithmic scale. It does not appear to be a straight line. That's not a good option. Okay. Remove it. Let's try it on the second axis. We could try it on both axes. Logarithmic scale. Ooh, now it's a nice straight line. So the type of trend line, let's take a look at the equation on this. We would get, this is fairly straightforward. We linearize this data by saying y equals m logarithm of x plus b. Now if we put in the trend line, okay. Now if we put in the trend line, we don't have to worry about this or this. It just converts it to, it just takes the logarithm of x, y equals this. So, and it just finds the slope and intercept from that. So let's go ahead and do that now. Get out of my drawing tool, go back over to the chart tool, and there we go. Add chart element, trend line, more trend line options. Logarithmic. When the scale of the x-axis is logarithmic and the data appears to be a straight line, it's a logarithmic model. And it fits exactly. Display equation, display r squared. And let's make it nice and big and fat so you guys can see it. There. And I'll close this down. So this is theoretical data. It's not experimental data. So r squared is exactly equal to 1. The line fits perfectly. And we do have m equals 9 minus 610, and b is 2084.8. So that's logarithmic fit. When the x-axis is on the logarithmic scale, the data appears to be a straight line. So we're going to wind up this video here and go on to other types of fits in just a moment.